Hello, my name is Brandon Beecham. I'm a sales engineer with Bytecode, and I'm going to walk you through our showroom on performance. This is the ERD for the data set we are working with today. We have a large fact table with over 1 billion rows and 18 columns. Each row represents a set of prescriptions given by a specific physician on a specific day for a specific age group in a specific time zone. The measures are the total count and average days supply. We also have aggregate tables that Looker is building and managing. The monthly aggregate is rolling these measures up by month, brand, and specialty, and the daily aggregate table is the daily version of that same aggregate table. We can query each of these tables in BigQuery and see their row counts. The fact table is 1 billion rows, the daily aggregate table is roughly 343 million rows, and the monthly aggregate table is roughly 69 million rows. Now, as we dive into the development environment where the LookML lives, this is the Explorer and Looker for this fact table. It specifies the cache settings for this Explorer and all the content built from it. It also specifies the definition of the two aggregate tables we are using, and it also specifies the data group trigger, which is the rule for which the tables are built on. So now let's go to a dashboard of the tiles that's built from this Explorer. As you can see, the two tiles that leverage the aggregated tables, brand and specialty, load first. But even the other tiles that are not using aggregates are still loading pretty fast in about a few seconds. So now that the dashboard has fully rendered, I can reload the dashboard and it all takes sub-second because it is cached. None of the tiles actually queried the database because the results were cached locally. In scenarios where data is loaded daily, it is common practice to load the cache for each of the common dashboards to make them super fast. Let's drill in to demonstrate Looker's ability to slice and dice on massive data. As you can see, I can drill into the billion rows with great performance. Each of these drills is also cached to speed up drills for others to use as well. I can even drill directly into a measure to pull row level detail from that full fact table. Let's go behind the scenes now and show what Looker is doing. If I simply count prescriptions, Looker writes the SQL to pull from the smallest table to achieve the right result. As long as I bring in dimensions that can be answered with this table, it will continue to leverage it. So when I pull in specialty and brand, it still pulls from the monthly table, which is the smallest. However, if I ask it to show me the result by day, it will no longer use the monthly rollup and switches to the daily rollup. And if I select a specific age group on that day, for example, which isn't a part of any of the aggregate tables, it switches to the full 1 billion row fact table to build the query. Regardless of the interface, Looker will leverage the best aggregate for the query based on performance and cost, thanks to aggregate awareness. Looker tracks every query a user runs, and in the usage analytics dashboards of Looker, you can get great insight into all query and model performance. Specifically, we can build tiles like this one that specifies the query elements that are A, the most popular, and B, also the least performant, which can help guide you on what aggregates are the most impactful for your users. Looker's performance capabilities are very powerful and easy to set up and configure. I hope you found this overview useful. Thank you for your time and have a good day.